In this video, I'm going to demonstrate how the Safe & Sound Pro 2 accurately displays average powers while measuring a pulsed signal with duty cycles down to 1%. Here we go. For the setup, we're using the HP signal generator at 2.4 gigahertz with a pulse digital input signal of 2 kilohertz from the Rigel function generator. And to monitor the modulation signal and duty cycle, we're also connected to the oscilloscope here. The test environment is an RF reverberation chamber with the RF stir stationary, since we're just testing at a single frequency and are looking at relative power only. So for this test, the nominal power I've got things set to at the test position is about 1,000 microwatts per square meter. As we demonstrated in a previous video, let's begin with a continuous wave signal and then introduce a pulse width modulation starting at 50%. So right now in the chamber, that background measurement that we're seeing around 0.071 microwatts per square meter, that's generated from the video camera itself in the chamber. So I'll turn the RF on right now, and this is a continuous wave CW signal around 1,000 microwatts per square meter. So now I'm going to set a pulse width, modulate it with a 50% duty cycle pulse width, and when I do that, we see the average now going just below 500 microwatts per square meter, and up to 506. Okay, now I will take us down to 10% duty cycle. So when we can see that on the scope here, 10% of the time the signal's on, 90% of the time the signal is off. And if we look at the meter here, we're seeing 99 microwatts per square meter. Theoretically it should be 100, but it's 99. Let's now drop to a 1% duty cycle. So you can see the very narrow needle spikes there, showing that the signal is actually on only 1% of the time. And if I go up to the meter here, we're seeing 8.9 microwatts per square meter. So slightly low, but very close considering. Okay, now if I choose to drop this down, let's go to 0.5% duty cycle. And again, these pulses are extremely narrow. I can widen them out a little bit so that we can see here. If you look at this, the horizontal time frame is 5 microseconds. And so we're looking at probably 2.5 or 3 microsecond pulse width. And we're seeing the meter measure 4.16, somewhere around there. A little low, but it's catching those pulses and accurately measuring a 0.5% duty cycle.